there's a log of pages at the front of the POH. And if you go to the log of pages, you're going to see there's a section approved by the FAA and a section that doesn't require FAA approval. So what you'll notice is the weight and balance section itself is actually not part of the FAA approved documents. So it's not necessarily a limitation of the aircraft in terms of how to fill that paperwork out. The FAA or Transport Canada doesn't really care the format that Robinson presents their weight and balance amendments, so long as it goes into that limitations chart and it works, the math works out in there, they're happy. So what you'll notice is the limitations section only has like the maximum weights and all that stuff, but it also has the CFG limitations. So how much forward and aft or laterally can that CFG move? We have our weight limits. So we have our maximum gross weight, we have our maximum or minimum gross weight, maximum per seat, and then maximum including luggage in that seat. So 300 with 50 pounds of luggage. Those are combined weights. You can't put 300 pounds of person and then 50 pounds of luggage. And then there is, again, a little bit of a note there in regards to what the minimum solo pilot weight is as well. Now, in order to calculate out weight and balance, there's a few different formats that this might get presented to you in. Airbus and Bell, I think, use kind of like a flowchart method. Once you've completed your flight test and you've done it manually, you should know how to do this manually just in the event you had to. But realistically, there's a ton of flight software out there that will just do this for you. But the first thing you do is you go to page 6-3 in the POH, and that's going to be your weight and balance record. And so the weight and balance record should have the list of amendments that are applicable to that helicopter. So if it's been approved or has maybe those bear paws on it, or even things as simple as like them taking out an altimeter, like the instrument itself, it actually changes the CFG, obviously quite marginally, but they do actually update the CFG amendments for that. Duals in and out, doors on and off, all of those things can affect the weight and balance. And so the helicopter, when you look at a base weight and balance amendment from this record, it is presumed that the cyclic and collective, as well as the pedals on the left-hand side of the aircraft, are in, as well as all of the doors are on. So that's kind of where they're doing that with, right? Is like doors are on, all that extra stuff is on. Now, you're just if you're removing that stuff, then you have to remove the weight as well as the arm or moment from that. So I'll show you what that looks like in a moment. They do have a list of all of the weights here. So if you go to, I think it's 6-4, they have a full list of like forward doors. They weigh 7.5 pounds each, and they have a longitudinal arm of 49.4, lateral arm 24, and they're just going to give you each of those values for each of those different items. And they also might have a little bit about the fuel. Whenever you add fuel, it just brings CFG forward on a 44. Everything is forward of the mast essentially. So whenever you're adding any weight, you're always going to be basically moving the CFG forward. You're never, I mean, theoretically, I'm sure it's possible to put it out of aft CFG limits. I don't know how. I'd have to go look. In the POH, there's a sample loading calculation, and then there's a loading calculating worksheet. So I'm going to kind of look through the sample one. We'll work our way through, and we'll kind of give you a scenario, and I'll kind of show you how this system works. Right? Weight times arm equals moment, and I'll show you why that's important, and we'll jump to it as we go through, because you can mess your calculations up if you don't use that. So in this example, they have a basic empty weight of 1510, a longitudinal arm of 106.5, and a lateral arm of 0.2. Those values would be given to you from your specific aircraft. So that is entirely aircraft dependent, and that will be in your pilot operating handbook. So maintenance will have weighed this aircraft out, its empty weight, and then they'll determine the CFG and they'll determine the lateral as well as longitudinal arms on the aircraft. And then you take that info and you apply it and implement it into this calculator. And then from that point on, everything else is basically just you plug and play kind of. You just take the 1510, you multiply it by the longitudinal arm. So we're going to do two calculations here, and the longitudinal moment is going to be quite large, typically like 100, like this one is 160,000, 815, quite big, right? The same again for the longitudinal arm, and then you just fill those in, and then you work your way down. So this one, they removed the front right door. So we looked back at that previous chart, they had a little note of how much each of those specific values weighed. So in this case, we've removed 7.5 pounds of weight because that's how much the front right door weighs. We've taken it off, so we have to take that weight off. And so we take negative 7.5, we multiply it by 49, and that's going to give us negative 371. It is really important to keep those signs. So if it's a negative value, keep it a negative value. And write that in your moments. So again, they did the same. They took negative 7.5, multiplied it by 24, and that gives you negative 180. Now the rest of the doors here, they have left on, so we don't need to do anything with them. You basically just ignore them all. So we don't need to worry about the left door, the right door, the aft left door. The cyclic and collective, as well as both pedals, have still been left in. The pilot in this case, in the forward right seat, weighs 170 pounds. We do the same thing. You just take 170, multiply it by 49.5. It's going to give you a moment of 8,415. And then 170 times 12.2. It's going to give you a lateral moment of 2,074. And it basically just works its way through each of them on your way down. Now what we do with all of those values is we're going to add the weight column up. We're going to add up the longitudinal moments, and we're going to add up the lateral moments. Do not add up arms, because if you add arms up, it will not work. It will mess the math up, and you'll end up with an answer that's wrong. So basically what you need to do, we got 1510, we subtract 7.5 pounds. Then we add each of those pilot, passenger, aft, right passenger, aft, left passenger, plus all the baggage weight up, and we get a total weight of 2,212 pounds, 0.5. And so that's our zero, our weight with no fuel on board is what I should say. So if we ran the helicopter, we kept flying it until we had no fuel left, this is what our aircraft's weight would be before we added any fuel. And then we're going to have our moments. So we've added up all these numbers, the 160,815 plus the negative 371, the 8,415s, 13,515, the 440s, all those together, we add them all up and we get 205,979. And then we do the same for the lateral. So we basically just take all of them and we add them all together. So now we have our WAM equation. So we have to take our moment and divide it by our weight. So if we have 205,979, we basically just have to take that and divide it by our zero usable weight in CFG. So we take 205,979 divided by 2,212.5, and it's going to give us 93.1. And that's going to be our longitudinal arm. And doing the exact same thing for the lateral arm as well. So you would just take 306, divide that by 2,212.5. And typically the lateral arm is always quite small. So also if lateral is negative, be aware, keep that negative and positive sign, because that indicates whether it's left or right on the aircraft. It will tell you up top, so it'll say lateral arm positive equals right side. So I'll show you what that means on the little diagram once we go up to the top. And then what we can do is we can take our fuel, and so in this case they've given us a number, so 6 pounds per gallon of avgas. So if we fill those, so in this case they've added 177 pounds of fuel. I guess we could do the math and figure out what that is in total gallon weight, or in total gallons. But essentially you just take, let's say you put in 20 gallons, you multiply that by 6, and you take your resultant and you put it in for your main as well as your aux. And then you do the same thing over again. So we're going to take our 177, multiply that by 106, it gives us a moment of 18,762. We do the same 177 multiplied by negative 13.5. It's going to give us 23,990, and then the same for the aux fuel tank. You can do both of them. Yeah. And then again, what we're going to do is take that 2,212, add the 177 pounds of fuel for the main tank, add the 102 pounds of fuel for the aux tank, and that's going to get you a total weight of 2,491.5, which is like 8.5 pounds off of the max gross weight of the helicopter. So you're pretty much at max gross weight. If that number at the bottom there was greater than 2,500 pounds, you're over your max gross weight limitations. We're going to plot these three, the 0 fuel, and we're also going to plot the max gross. We're going to take them and we'll plot them up in the limitations section. And so we have this lovely chart, which is going to we have 2 sections to this, and this is kind of one of these things that's unique to helicopters. Normally in airplanes and stuff like that, they'll only calculate out longitudinal CFG. So when we talk about longitudinal CFG, we're just talking about how does it affect us along the length of the aircraft. So basically from the tip of the tail boom to the nose of the helicopter, where is that weight sitting on that teeter-totter, that imaginary teeter-totter? Is it really heavy on one side, really heavy on the other? And then when we talk about lateral CFG, how is it affecting us side to side? Are we having lots of weight on the left side of the aircraft, not as much on the right? So it's going to kind of influence and tell us a little bit about how our pickup on the aircraft is going to look. So what you'll notice is there's a whole bunch of stations at the top. So these are fuselage stations, and they're going to be giving us specific inch values along the length of the helicopter's body. So we have from 91 to 103. And our basic longitudinal limits are from 92 at the back up to 102.5 at the front. So we have about 10 inches of movement across the length of the longitudinal axis. This 100 datum point is actually the main rotor, and then as we move this way to the left of the paper, it's actually moving forward. So this way to the left is actually to the front of the helicopter, and then the smaller portion on this segment over here is actually the aft of the main rotor in that direction. It's actually quite hard to put it out of lateral CFG as well. You basically need to fill up the main fuel tank and put two 300-pound people on the left side of the helicopter. Like, it's actually quite difficult as well, but you still have to check the lateral CFG limits. Just to clarify, right is positive. So if you get a positive value for your lateral CFG, it goes to the right side. If you got negative values, it goes to the left side. We're going to look at our side here, and it has from 1500 up to 2600 on the side, and that's our weight. So we're going to start with our empty weight. So remember, we calculated out our empty weight with no fuel. So we're going to go back, and that was 2212.5. So we find 2212, so we're probably, this is 2200, maybe slightly above it, right? And now what we do is we look at this at the top scale. So at the top scale, we have from 91 to that 103, and this is our longitudinal value at the top. So we're going to find our longitudinal value that we calculated, which was 93.1. So if we go up here, we find 93. And so we're probably just slightly ahead of 93.1, and we're probably just kind of in this range over here, right? We're just slightly above 2200, just slightly to the right of 93. And we can add a little dot there. And so that's going to indicate where our empty weight with no fuel on board is going to be located. And then what we can do is we can take our second number, which was 2491, and we can find that. So we can go up to 2400 here, and we're actually getting a little bit closer on the top half. And then we had a fuselage station, or longitudinal station, of 94.4. So move ourselves over. We're kind of halfway over here in this region, and we're going to make a second dot. When we're flying along, this is going to be moving from the top one down to the bottom one. And also you have that little dashed line there. And so everybody's like, what's that for? All that's telling us is it's our most forward CFG with full fuel. So if our full fuel, if we had taken our full fuel dot and our full fuel dot had been on this line or forward of this line, that means that as you fly forward and you burn more and more fuel, your CFG is becoming more and more forward, and you're actually going to end up outside of limits. It would be like, if it's forward, you're going to end up outside the limitations, right? So now we take a look at our full weight versus our empty weight, and we're actually outside of the limits of the aircraft. If you fly along and you're burning off fuel and your CFG is becoming more and more forward, what is a problem that you might encounter? Why is that so important that we don't have that happen? Yeah, exactly. You nailed two of the big ones right on the head right there, right? Like auto rotation, or you're coming in to come land again. You don't have enough aft cyclic to slow down potentially.